Analog and digital, question 1. First part, AI. What is the difference between analog and digital signals? Just 1 mark for this, so all we're looking for is that analog signals are continuously varying or can take any value, whereas digital can only have 2 possible values, which are taken as 0 and 1, or off and on. For A part 2, give 2 disadvantages of analog signals compared with digital signals and explain. Now there's 4 marks for this, so it's going to be 1 mark for each disadvantage and a mark for each explanation. Well, analog is more affected by noise, that's the disadvantage. Bit more of an explanation. Well, with a digital signal they can pick up noise, but can then be regenerated, so easily removing any noise. Also, with an analog signal, it's 1 wire per signal, whereas with digital you can send many signals down the same wire by using multiplexing. Now we're given a diagram of the signal as it was sent and the received signal, and asked, was the signal sent along copper or optical fibre, and an explanation. Probably there's no mark for stating either copper or optical fibre. The mark will be for the correct explanation. Well, it must be copper. The signal would weaken in an optical fibre, getting below the initial 0.6 volts, but it would not have picked up noise. For the second part, give 2 reasons why the received signal is different to the sent signal, and explain. Again, there would be a mark for each reason and a mark for each explanation. Well, the 2 differences: this signal is jiggly, it's picked up noise, and also this signal is below the initial 0.6 volts, it's generally weakened. The noise, or electromagnetic interference, has superposed with the original signal. That can happen if there's other electromagnetic radiation around the cable carrying the signal. Also, energy has been absorbed due to resistance in the cable. This would have caused slight heating in the cable and has caused our signal to fall in value. For B part 3, give suitable ranges to be read as 0 and 1 if the received signal is to be read without error. Well, for the 0 to be read without error, we need to ensure that none of these spikes would go above our 0 boundary, leading to a spurious 1 signal. So around about this sort of level, or even up to here, would do. For example, the area enclosed by the blue there, from 0 to 0.2 volts. So we could have the 0 range from 0 to 0.2 volts. A lower signal down to around about 0.05 volts would be acceptable. For the 1 values, we need to ensure that none of these drops will be below it. So something like the red region here would enclose all of those regions, somewhere from around about 0.3 to 0.6 volts.